Let's begin the forum. I see the speakers. The first speakers are already there. Claude and Annette. Hello, both of you. Nice meeting you. Meeting you.
Yes, hello.
I think that we're going to start while letting everyone join us, okay? Because the time is here and we try to meet the timeline. So I can see everyone, I can hear everyone, and the presentation is being managed by Fleur, right?
Yes.
Great, thank you. So let's start and let's begin and let everyone else join us. So good afternoon and welcome everyone to this is the Winter Irrigation Forum. This time passes. For those of you who don't know this format or don't know us, this is part of the irrigation, the European Irrigation Association events that we're doing 4 times a year normally, maybe sometimes 5, to share knowledge and understanding and interesting topics for the benefit of everyone, mostly the members of the Irrigation Association, and then everyone else. It's an open forum. My name is Moshe Bernstein. I'm the president of the association, and I'm also the director manager of the company Netafim in France. I'm very happy to see you all here, and on behalf of the board and my colleagues here, I would like to welcome you to this event and I'm glad and I'm very happy to see you all, members and visitors. So as always, the housekeeping rules are the same rules, different events. We are recording this event, so please, if you don't want to share your identity or your name or video, just be aware of the fact that everything will be recorded. If you have no problem with being recorded, so we'll be very happy to see your full name and the organization, so we get to know you a little bit better. Please mute your microphones as always, unless you would like to join and talk. The chat box is always available for questions and comments, and we encourage you to ask questions and to have more comments, because this is the reason we're here, is to share, and we love to get feedbacks on the creation of interest by everyone. And if you can turn on your camera, some of you already did it. We appreciate it a lot, because we find it also very but much more communicative that we can see each other in these forums. So let's next slide, please, Fleur. So the code of conduct before every just for the avoidance of misbehavior, I would like to mention again that this is an environment of free competition. We adopt a very strict code of conduct in all occasions, all events, meetings, forums, and so on of the association, meaning that simply saying we're not talking about anything which has any commercial aspect or any exclusive information. We don't share, we don't boycott, we don't talk about results or about financial aspects. We just concentrate on what we hear. What we do best is to try to promote a sustainable irrigation together, and this is a crucial aspect of every intervention that we're having. Next, please. So the agenda. So what do we have today? We start by a short introduction to where we are, the ongoing of the association, what's going on. Usually I'm doing this, sometimes Bruno as well. This time I'm going to take the lead and just to share with you some of the excitements that we're having now around sustainability and in the EU Commission. Then we're going to move to the introduction about where Fleur, our communication officer, Fleur Martin, will provide us a glance on the newcomers. I think that today we have 3. I'm not sure if we got the 4th one already, but we have 3 newcomers, if I remember correctly. And Fleur will introduce them to everyone. and then we're gonna have our main speaker, two speakers today, which already I see them in the video, Annette Berard and Claude Doussan, from the organization, from the research center of EIA, and they will share with us. They will get us a close glance in the area of the roots. We talk about plant, soil, and water. I'm sure it's going to be very interesting because it's a topic which is very relevant to what we do in the irrigation sector. And I'm looking forward for the session. Of course, after the session ends, you will be more than welcome to ask questions, comments, and to share your opinion on this one. And the last part will be, as always, the innovation technology session. We open, for those of you who know already the association, the forums of the association, we open the stage for one of our members to share innovative breakthrough technology and new innovation that can be interesting for everyone. This time we're going to have Andreas coming from Germany. We'll talk about a smarter way to design and operate irrigation systems. And then, of course, you will be able to, I see you already, hello. And then we're going to be able you will be able to ask questions and to take this to wherever you like. At the end of the session, usually we still have some, if we still have some more minutes for us, then we open the session. You are much more than welcome just to open your microphones and your cameras and to ask questions. Anything that comes, any comment, question, or remark will be more than welcome. As I already mentioned today, we are here for you, and we'd like to share and we like to communicate. So this is for the agenda. I think that we can go to the first topic already, which is introduction by also the taxonomy. So few words that I would like to open this session on the ongoing of the association. We are mostly focused today on the link between irrigation and sustainability in the context, the European context. Sustainability tool, the main sustainability tool for finance of sustainable growth and economies is the taxonomy. It's the classification of activities. Since almost a year, I guess, we've been working. Well, less than a year, but we've been working very hard on the preparation of the positioning of the irrigation sector in Europe in the context of the sustainable economy. We've been working on the preparation of the first ever official document that was submitted to the European Commission last December. Around the place of the irrigation in the sustainability activities in Europe. We've created this paper that you can see in the presentation here. This is just a cover. It has like 50-some pages with a lot of information that puts the baseline for what does it mean irrigation in the context of the sustainability. This is actually the first time that we really try to identify where do we start, where do we stop, what does it mean, the value chain of the irrigation, which activities, technologies are included, and how do we tend to measure them as well. So this is really the vocabulary, the basic terminology and vocabulary that we've published, and we send it to the European Platform of Sustainable Finance. Now we're waiting for the dialogue to be opened, or hopefully the finger crossed that it's going to be a fruitful one. At the end of the day, we're going to find ourselves promoting the voice of the irrigation in such a way that we will be considered to be a legitimate economical activity within the context of the taxonomy. And this will open many new opportunities for all of us in the sector of the irrigation in all cycles. Next, please. Oh, sorry. Before next, I forgot to mention. Yeah, sorry, Fleur. I forgot to mention, but it's very important to say. and I'm going to repeat this as well, my sincere thanks and appreciation to all the people that took part, are still taking part in this activity. It's a very intensive, time-consuming, and enjoying activity. And we have participants from in many technologies, many aspects, many countries, many people that are taking part in this in making this project happen. Both contributing money, and which is the fundraising that we did last year, the end of last year. You can see the names of the companies who contributed not only time but also money. But there are many other people which contributed. You don't see their name yet here, which significantly contributed to the success of this project. And I thank you from the bottom of my heart on this one, because this is the way we create the mutual value that we can bring to Europe irrigation. Next, please, Fleur. Just for those of you who forgot, or if you by any chance hear the taxonomy, the name taxonomy for the first time. So taxonomy, it's not about text. Just a few words of as a reminder. It's about classification. Taxonomy is the name of the classification system in Europe that sets the rule of what does it mean sustainable economy activity, what's green, what's less green or greenwashed. And this is part of the agenda to reach carbon neutrality by 2050. And the European Commission has introduced this term of the classification and mechanism a few years ago. Once we found out that irrigation is not part, doesn't apply anything on this. It's not part of the taxonomy terminology. It's not part of the context of the economical context of taxonomy. That's where we entered, and we start moving towards positioning the irrigation as a legitimate activity to be classified in the future, not only as activity but also with the terms and conditions of what does it mean good or sustainable irrigation, as we claim in our logo, because that we aim to achieve and to promote. So yeah, we're very excited, as you understand from this, with this advancement. Next, please, Fleur. And just to maybe you take this opportunity to, I think, I'm sorry, I forgot about the recommendations. Yeah, before I invite you to join a webinar around this. A free and open and nice webinar around this, but just a few words about it's not only about what we put as a basic conditions and rules and terminology on how to do irrigation, what does it mean irrigation with the technical aspect. We're taking this also to the next level and trying to move forward with the commercial research partnership aspects of what does it mean to be part of the taxonomy, to take part of the sustainable activities in Europe, and we are aiming to reach 5 different groups of audience, 5 different profiles, to continue advancing this topic. One of them is the irrigation companies themselves. And what does it mean for the irrigation company to be sustainable and to reach and to teach and to have the knowledge, to pass the knowledge on what does it mean and what you should do. But not only here, we continue working on the value chain. We're not alone. The irrigation of the agriculture, for example, the irrigation that concerns the food chain. So we are creating an interest with other organizations. We will continue creating and will create more and more interest for everyone to take part of this. You can imagine one day that we're going to have, maybe soon, we're going to have a sustainable irrigation certification, for example, for the final product that the food chain will be able to use to demonstrate the responsibility, ecological responsibility on how to use water, for example. So it's an ongoing thing. Now we're just putting the baseline for everything. But once we're going to be there, then there are many aspects of international collaborations with other associations, with other organizations, of course, on the standard and on the norm, the standards and the research, and up to the point where we reach the final sector, the financial sector, and we reach the investors that will help us to move forward the best practices of irrigation. Next, please, Fleur. And by this, I will stop here by inviting you all, the people that are in this forum and your colleagues, friends, and other people. We're gonna have a 1 hour open webinar in 2 weeks from now. It's going to be on February 9th at 12 o'clock Central Europe time, and we will present the project. We will present the results, the headlines, and the content that we've published, and what are the expectations. Of course, we're going to open this the forum for question, discussions, and so on. So some of the information is here, and if you are willing, if you would like to get the direct information, you can contact the Fleur, the communication officer of the Irrigation Association, myself directly, or maybe, I'm not sure, Fleur, if we have it also on our website. But
yeah,
sure.
you can register directly on the website. There is on the homepage you will see the invitation for the webinar, and you can register.
Beautiful. Thank you, Fleur. So just look for the European Irrigation Association, the web, and you can enter. You can continue from this point. So looking forward for these activities, and looking forward to seeing you there. And I think that this is the time when I leave the floor to you, Fleur, right?
Yes.
Good.
Okay.
Thank you.
So thank you, Moshi, for this presentation. Now we move to the second part of the forum, which is the welcome to new members. Today, we are very proud to say that we have 80 members in the association. They are not only manufacturers, but we have more and more people from the research universities. We have some distributors, some installers. And now it's time for the new members who joined us since our latest forum to introduce themselves and their company. So I will call them one by one, and they will have 1 minute, or 1 or 2 minutes to speak. So the first one is Mr. Fabio Vescovi from the company Cropin, if he's here.
Yes, that's me.
Yeah.
Good afternoon, everybody. As said, my name is Fabio. I am an expert in remote sensing technologies applied to agriculture, and I'm here to present Cropin, a company which was founded about 15 years ago in India, but now it's scattered all over the world, also in Europe, and I'm speaking actually from Italy, from Europe. And the company essentially provides digital agricultural services for essentially for the farmers, but not only. We provide services also for institutions, governments, FAO, and generally the world of the agri-ecosystem. We are here to learn a little bit also to improve our services in the area of agriculture. Essentially, what we do is to offer through a platform. You can see an example of this chap, a young farmer using our platform to take decisions. Essentially, we process data through our artificial intelligence algorithms. We process the data, especially satellite data, in such a way that eventually the information given to the farmers can be used to take decisions, very simple decisions like opening or closing the tap for water, for chemicals, for fertilization, for herbicides, etc., etc. This is our role. We are very happy to be here and to learn some more about improving our applications, especially in the area of irrigation. Many thanks also to the introduction from Moshi and Fleur in this area. Thank you very much. I'm very excited to be here.
Thank you, Fabio.
Fabio.
Welcome in the association. So we are going to move to the next new member, which is Mr. Miguel Agostino from the Portuguese company Hortus.
Hello to everybody. My name is Miguel. My company is Hortus, and we work in the landscape irrigation design and some installations too. We are available to work with association to try to develop new irrigation technologies and try to develop everything around irrigation. Thank you.
Thank you, Miguel. Welcome.
Thanks. Welcome.
And the third newcomer is the company Iris-Sketch. It's a German company, and Theo Wirtz is going to introduce the company.
Yes, hello. Thank you for being here at the Irrigation Forum. Yes, Iris-Sketch. We are located in Germany, and we provide a web-based planner for irrigation systems. So it's for residential irrigation mostly, and our main goal is to get more designers inside irrigation business. So what we see is that our design software and design tasks for irrigation professionals are always a big task. It's very time consuming, and most of the time, it's not the most popular task in our job. So Iris-Sketch is here to change everything in this area, because we are able to build up a complete new system. It's web-based, so you don't have to download some software on your computer. You can use it at your computer, at your tablet, or maybe at your smartphone. All what's required is an online connection, and we are able to show the whole design process. First step with the request from customers directly inside Iris-Sketch, then the whole design project with all kind of manufacturers also inside, and then at least have a specs sheet and to use your own price lists to get a fast quotation for customer. Thank you.
Thank you, Theo.
Thank you, Theo. Welcome.
Welcome. Okay, so this is all our members, the logo of our members. So like I told you at the beginning of my presentation, you are now 80. So this is very, very good number. 4 years ago, we only have 34 members. So the association is really growing actually, with many interesting projects like taxonomy projects. Moshi presented you. Okay, so now we are going to move to the next part of the forum with our invited speakers, Claude Doussan and Annette Bérard from EIA, and they are going to do a presentation about the soil health and water. So I will stop sharing my screen and give the hand to Annette and Claude.
Yes. Annette,
you can share your screen.
You're still on mute, Annette. So if you would like to open the microphone.
Yes.
Now I can hear you.
It's okay. Do you see the presentation?
Not yet, but it's coming now. We can see. Yeah, I can see it.
Yeah,
okay.
yeah.
So, so thank you very much for your invitation to present our works, and we will present together with Claude. And Claude will begin the presentation, and after he give me the place to present. So Claude.
so yes, thanks for the invitation and the Irrigation Forum to give the opportunity to present our works and some ideas. And the talk will be about plant soil and water, and we will look more precisely on the special zone in the soil, which is called the rhizosphere, where the soil and the plants interact. So Annette, can you? So as a global background, as you all know, that there's a problem of climate change presently, and this climate change implies some higher frequencies of drought event or intense rainfall events. and it has consequences on crop water deficit, and so consequences on the yield and quality of crops. But concerning the rainfall events, it has consequences on runoff and infiltration in the soil, and it raises problems about waterlogging in the soil, erosion, flooding, and better aspect is groundwater recharge. So if we want to fight against that, we have some solutions presently which are technical. And so you all know that irrigation has increased recently in the last 10 years. And it's a solution indeed for problems of water deficits. There's more and more use also of reuse of treated water, wastewater. But there's also other solutions. Genetics is also another solution by the improvement by breeding of the varieties. There's also agronomic solutions for fighting against droughts concerning indeed varieties, but also plant densities, what you put on the soil as amendments, etc. And for fighting against the consequences of intense rainfall events, also can work on the soil about tillage, you can have some equipment, you can have also agronomic solutions as cover crop, grass strips, etc. So can we have other solutions in the future as another lever to increase for crop water deficit? Could we increase the soil available water capacity, the maximum amount that the soil can retain as water? And for the rainfall, can we modify the soil surface and the deep soil and filtrability for water? In that context, the idea is, can we use the plants and their root system to reach these goals? So for the next slide. As you all know, so the soil itself has some physical properties, and one of the properties you all know is the water retention, for example, which is linked to its porosity, this wettability, stability, but also properties are linked to the chemistry and the microbiology, and all these properties will next act on the plant, and so the plant had to adapt to these soil properties, and that will influence its uptake of nutrient and water. It will influence growth, the soil properties, the yield in the final step. But what is less known is that the plants also act on the soil, and there's much less things known about this, how the plants modify the soil. So one thing we can have a look very simply is that plants, once they are growing into the soil with their roots, they can create holes. They are creating porosity. But they will also destroy porosity when they grow into the existing holes. So it's directly linked to the root architecture. So it's what we call the direct action of roots in the soil, but you have also indirect actions of roots in the soil, which is linked to the fact that roots leak carbon, organic carbon, as much as 30% of the total photosynthesis can be leaked into the soil as what we call rhizodeposits. And you can see on this slide, I don't have the, I would show the drop if can. It's this kind of drop, this viscous drop is what we call mucilage. And it would be this organic carbon will go into the soil and interact with the soil and microorganisms in the soil. Next slide. So it can have some influence on the hydric properties of the soil in a rhizosphere. And the rhizosphere is, on the next slide, a small zone of the soil which is influenced by the roots. And this small soil zone influenced by the roots is largely influenced by this fact that roots leak organic carbon through mucilage and rhizodeposition. So all along the roots, you will find this carbon released by the roots, which will influence all the microorganism, the bacterial life, which will develop on this carbon. And the exuded polymers, like it's called EPS on this slide, which means exopolysaccharides. It's a long polymer chain. We are very specific. Will serve as a source of energy for the microorganism, but it will also modify the properties of the soil. In particular, it can modify the water retention. EPS, exopolysaccharides, are themselves water retenters. And they can modify the soil aggregation too. And so it's very important to know that, because all along the roots, all the water that came to the plants go through the roots and through this small soil zone influenced by the root called the rhizosphere. So if you modify, if the properties of the rhizosphere are modified, you modified the way the roots are taking up water in the soil. So on the next slide. So on the next, in the presentation, we will show you some of our work. Annette will show you some observation of this rhizosphere effect.
Yes, so I will take 3 examples of observation we have done last years. The first one was in the field with maize, and our purpose was to see if there was a real rhizospheric, difference between the soil near the roots and what we call the bulk soil, the bar soil, not near the roots. So here you see we are in the field, and you can see the what we call the rhizosphere is just the soil we sampled near the roots. And we sample to compare soil between the rows. So our observation was to in the three characteristics of the soil about biological characteristics. For example, microbial biomass. We saw that the biomass in the rhizospheric soil was higher than in the bulk soil. But also in chemical characteristics, like as Claude said, the exopolymer, exopolysaccharides in the rhizosphere, which were higher than in the bulk soil. And we saw also about hydrophysics characteristics, a higher water retention in the rhizosphere. So that was observation. And we also see that kind of results in other contexts. I will show you after about tomatoes, for example. What was interesting also that there was a relation between the exopolysaccharides measured in the soil and the water retention of the soil. And we found also some correlation between microbial biomass and activities in the soil and that water retention in the soil. You can see the green dots on the left, which represent the rhizospheric samples, soil samples, and the brown orange dots on the left, which are the the bare soil, the bulk soil samples. Another information was about microbial communities. We applied to this soil sample a kind of heat wave perturbation, higher temperature and high Drew. And we observed the resistance and the resilience by the microbial respiration of these different soils. And we saw that on the green here was in the rhizosphere. You have to see inversely, but the resistance and the resilience was higher in the rhizosphere than in the bulk soil. So to summarize these local effects, and I insist it's in field observation, not in laboratory. We found an effect on the hydraulic properties of the soil and the response of microorganisms to a heat wave perturbation. Another example was in a greenhouse and with a wheat experiment. And this time we worked on 6 wheat cultivars, 2 irrigation conditions with a water stress and a control, and with 2 soil. We measured similar properties that we have done on the field and on the maize field, but also we measured the stomacal conductance of the wheat plants. So what we see was there was difference between the different varieties of wheat. Each dot represents a wheat variety. But here, what it was interesting, it was that we observed an inverse relationship between the decrease of transpiration that we observed with the stomacal conductance between the beginning and the end of the Drew stress, and the amount of exopolysaccharides in the rhizosphere of the soil sample. So in red, it was the plant which were not irrigated, and you can see that relation. This relation was for the 2 soils, but you can see difference between the 2 soils in the right and in the left. And we didn't find any relation when the plants were irrigated. So the third example was we returned in the field this time with 2 tomato varieties and 2 irrigation conditions also, and we measured it in 2 campaigns. What we saw, it was different property in the rhizosphere, different between the 2 varieties. So in red you have the Terradu variety, and in orange, yellow, it was Helms variety. What we saw in the Terradu variety, this time it was in the field capacity, but we saw a difference in water retention the rhizosphere soil between that two varieties, and concomitant with difference in exopolysaccharides amount also. So higher exopolysaccharides in the Teradu varieties. So yes, what I said. We have also information about plant performance, and I just show the result in restricted irrigation because we see higher difference in that condition. And you can see that in the variety, Teradu variety, which had higher water retention and higher exopolysaccharides and higher, but I didn't show it, microbial communities in its rhizosphere. We saw also a higher performance in terms of yields, but also in terms of water use efficiency. So what we can say that is that here again we saw a rhizosphere effect on the soil and water properties. I didn't show you, but it was as in a mice experiment. And microbial activities and exopolysaccharides explain partially this difference in soil water properties, and also this difference was different between the two tomato varieties, and it was in line with the difference in water use efficiency between those two varieties. So in summary, I think it's Claude who will speak now. Are you there?
Yes. So if you can add the slides. So through these different examples, you have seen more or less the same behavior of various variation in soil properties in the rhizosphere, where linked to EPA, exopolysaccharides, linked to the microbial activity, and inducing something underwater retention. And from the different examples we have seen on the last example, for example, with the tomatoes, that you reach different kind of response for drought linked to this. Of course, this is not only linked to this soil and rhizosphere properties, this is linked to the plants too. But we see from these different examples that maybe there is a link with rhizosphere properties. So on the next slide, to summarize, at the beginning of the talk, we have seen that the soil, this retroaction cycle between the plant and the soil, and on the next. So that's why we propose to have a look on using the roots and the rhizosphere to improve the water management. Next. But before that, we have for the moment some kind of basic research, of course. And what we have to explore further is, of course, the genericity of our results in different pedoclimatic conditions. We don't have examined all of the possibilities of soils and climate and plants. But what we think would be interesting is to characterize the rhizospheric traits, what we call rhizospheric traits of different genotypes or different agricultural species, and to give some access to what we call the extended below ground phenotyping, not phenotyping only the roots, but have some phenotype also the roots and the soil which interacts with the roots. So on the next slide. So we start this kind of thing through a little project at INRA in Avignon with colleagues about phenotyping. As you know, phenotyping is much more on the plant above ground parts than underground part because it's much more complicated to get information in the soil and on the roots for phenotyping. So we'll look at different phenolical stage of what happens and for the soil and the roots and the rhizosphere on seeds, on young plants, and on in the field also. So it's an experiment which is going on. And the second question is at the crop scale or the rotation of crop in time scale. And the question is, can we prepare the soil through the roots of the crop and the plants which are on this soil by diversifying the crops? And it's linked to what is more and more used now, which is called conservation agriculture, use of cover crops or living mulch or agroforestry, where we possibly prepare the soil in terms of desired hydraulic properties, possibly. And to show you an example of that, it is on an experimental site of INRA, where we have rotation between grassland and cereals. So there is one plot or different plots which are permanent grasslands, different plots which are cereals over cereals, and plots which are cereal grassland rotation. And you see it can be a rotation on 3 to 6 years between cereals and the grasses. And if you examine in this soil of this different rotation, the retention of the water, on the next slide, after 8 years or something like this, you can see on this slide, I can't show you with the pointer, but you see in orange, the different colors are the different rotation. In yellow, it's continuous cereals. In green, on the right, it's a permanent grassland. And in the middle, T2 and T3 are the rotations. And what is important to see is you have more water which is retained at field capacity on the rotation, statistically different from the permanent cereal crops or the permanent grasslands. So something happened with the rotation, and you increase the soil available water capacity. That means you could gain some water which is available to the crops in this kind of setting. So looking at rotation and which type of crop and cover crop you put, you can be a lever to modify the soil too. So I think we will end in the next slide with that. We want to thank you for your attention, and of course we will answer your question later. Thanks a lot.
Thank you, Annette and Claude. We're open for questions. I think there is a Bruno. This is coming from you, so I guess that
yes.
You can
yeah. Do you want me to? Yeah, I was just wondering because there is a lot of discussion about the technology of irrigation and the consequences on water management, and in particular. Well, thanks for the quality of the presentation. It's really lightning. And yeah, my question is, what can be the consequences on the long term of the use of drip irrigation that will only concern part of the volume of soil in comparison to other technology that cover all the soil. And the subsidiary question, how can we manage irrigation to be sure that these consequences will be minimized? Maybe it is not only irrigation, but also the type of practice in general. Thank you.
Thanks for the question. I don't know if Annette wants to start or I start.
Well, I'm not a specialist in drip irrigation, but so I have looked at different works. It seems that there are a few works on that question about drip irrigation and soil health. But one work was quite interesting because he compared a kind of benefits and a kind of trade-off between drip irrigation and other kind of irrigation. And what they saw that, of course, water use efficiency was higher in drip irrigation, and weed suppression also, which are very important. But in the long term, they have question about aggregation and also which is quite linked the carbon sequestration. So and another paper more recent, which was on also in field tomatoes, but in fertirrigation of tomatoes. They find that microbial communities were different between near or deeper the drip irrigation. So there are some quite difference, and they saw particularly that mycorrhizas, which are important for the growth of plant, were less present near the drip irrigation. It's just two papers, and it's just two questions, so I can't respond. But for me, it can be interesting to ask this question and to study more about not only in the short term the yield, which is good, but also in terms of other ecosystemic services of the soil, which can be lesser in that kind of drip irrigation. It's just two papers, and it's I'm not a specialist, I repeat, but for me it could be interesting to focus more on that questions. But Claude, you can say.
Can add some other information. For surface drip irrigation, I think most of the time, linked to the carbon, you have the carbon cycle is accelerated. So you have more decomposition of mineralization of carbon very often. So more CO2. But on the other side, there you have, depending on the nitrogen fertilization also, but less azote peroxide and N2O as greenhouse gases. What is clear is that you have more microbial activity, as Annette said, in the wet bulb. You have different mycorrhizas between the wet bulb and the dry zone. But what is to be considered is that you can't think only at just drip irrigation will be maintained all along the time. You have to think, I think, with the rotation. In fact, so it's different if you address, for example, a tomato crop, or if you address orchards, perennial and non-perennial. And in the case of non-perennial, you will have an effect of drip, of course, localized drip, but with the next crops, it might lessen the effects. So you have to see all the system when you are thinking about long term. Another thing I didn't said that, of course, all of that depends also on the climatic conditions, and something is highly known is the problem of salts in the soil, salt accumulation. With the drip irrigation that can arise sometimes, of course, but it depends completely on climatic conditions. But however, concerning all the things which are linked to soil health, as Annette said, I say, which encompass the microbial activity, the detailed carbon cycle, the aggregation of the soil, the stability of the soil, not so much is known, in fact, apart the great lines, as we have said before. I don't know if we answered to your question, Bruno.
Yeah, partly, but thank you. So the question is not really addressed in the as of today, and I understand why there are so many soil initiatives in research, and well, thank you for your answer.
Yeah, thank you very much. Also from my side, I think that there is another one, Michael. I think there is another question coming.
Yeah, thank you. Thanks a lot for the presentation. Yes, I had a question. I often work in urban landscapes, urban fields, and I was wondering, we used to say that when you work on the soil, you often put some more organic matter to make sure that the soil will offer better conditions for the plants. And my question is, the rhizosphere, is it a way to add some organic matter? Is it a similar way of helping plants to have a look at rhizosphere and organic matter generally, or are there completely different phenomena to make the plants grow better?
The nature of the organic matter is slightly different between the two. So when you add organic matter, you indeed the organic matter may add some is linked to the carbon cycle, but what is in the rhizosphere, the carbon in the rhizosphere is two kind of things. Very small molecules which are highly available to all the organisms in the soil, and big molecules which are less available in the first time, but which modify the way which by themselves are water retentions, I said, but also make a link between the particles. They aggregate the soil. In the case of carbon, you add that directly, it's already some kind of degraded carbon, and it's more targeted to mineralization, a part of it. So they are different in that sense. They are not from a chemistry point of view. They don't have the same effects.
Okay.
And also rhizospheric, as the name as it's said, it's near the roots. So I think there is a difference in space between put some organic matter, usually on the top. Eventually, you can melt it, but it's not the same scale, space scale, because what we represented in our presentation was about very, very close to the roots.
Okay. So I guess if I consider soil quality for making able plant to grow, it can be a better way to prepare the soil putting organic matter, but it's not the same quality as taking care about rhizosphere and considering what roots functioning will add for the plants. There are two levels of quality, I guess. Bring organic matter is not enough.
We think so.
Okay.
And it's
you change also
two different processes. So
okay. Very clear. Thank you.
Damir,
Yes.
you have a question? Yeah.
I would like to ask, from this or similar research, can you think of any practical guidelines which will have to do anything with irrigation scheduling, or the point when you start irrigation and when you end in the season? Do you are there any guidelines in terms of appropriate point when you start irrigating? So this is what I wanted to ask. Can you think of any practical guidelines for irrigation practitioners coming out of this research?
In fact, for this kind of alteration of soil properties with root action, if we can see something which is related to the field capacity or the permanent wilting point, things like this, it can be directly implied in the classical way of managing irrigation, in fact, concerning the available water capacity. But there's not this direct action on the soil. There's also indirect action with microorganisms that we don't speak a lot here. And irrigation linked to a better water use efficiency, I would say that like this, have to care with indirect actions and what is linked to a better life around the roots. And for the moment, we don't have the guidelines for you for that.
Well, for sure, we're looking forward to see what's gonna happen next year, because I think that there is a lot to be done in this area of the research and how to implement, following the question of Damir, and what does it mean for the irrigation practices, best practices for the efficiency of the irrigation. For even you mentioned previously the possible mix of different type of technologies for irrigation, drip and other technologies with the rotational crops, and so there is a lot to do. I think that the main message here is that things are being done, and we will need to be patient. We can offer our partnership always to explore more and more technologies, and to offer what we can as the best tools to manage this type of research. And we find it very interesting for the future of the irrigation to go more and more precise, and to give the best solutions for the face of the climate changes, and not only the technology but also involved with the agronomical part and research. So I found it very interesting. Thank you very much for this presentation, both Annette and Claude. Are there any? If there are more questions, please go ahead, open the microphone, or post the question on the chat. And if not, I think that Flo, right, we're gonna publish this. We're gonna the access to this presentation.
Yeah.
Part of what we're gonna publish later on, and then people can have
the presentation on the website next week, and also the recording of the event. You know, so you will have everything on the website.
Good. Thank you very much. Let's move on.
Thank you.
Thank you.
Thank you.
Thank you. Really interesting.
Yeah. So now we are going to move to the latest part of this forum, which is the innovation technology session. This time it's Andreas Maurer from the company DWS in Germany, who is going to do a presentation. And he will present its online innovative irrigation planning software.
Okay. Hello, everybody. Thank you for the invitation to talk. Do you see my presentation?
Yes.
Okay, then we start. So the presentation today I want to give is about a smarter way to do irrigation than just ET. And I tried to show the concept of a digital twin for designing and operating irrigation systems. So basically, we want to look at the definition of the digital twin. We want to look at one approach with like irrigation and data visualization, and then moving from like this conceptual irrigation planning to controlling the irrigation system. And then we end with some conclusions and next step, looking towards auditing and certification of irrigation systems, maybe in the future. So basically, the questions we raised, or like the industry raised, is like always around how to increase efficiency of the systems and to make them more sustainable. And so we today talk about this digital approach to irrigation management. And we look at these topics when we talk about water efficiency. So to understand the system's efficiency, and also to understand the watering needs of like the plants and the crops. And then we have this, what we heard in this in the first talk, that like the living environment is a big topic about that, and we try to map sensor data to this living environment to get some relationship between measurements and the living environment, to get some idea of the water demand. And then we talk about algorithms to start to calculate and make decisions with this data and with the information about the irrigation system. And this eventually then leading in some auditing activity, where we could make this transfer of knowledge from the initial irrigation design to the system operation. And this could, eventually lead into some certification process. And so to talk about the digital twin, it's just some general definition of all like computing activities. So we talk about a virtual representation. So the digital twin is basically like the virtual matched properties of the system, and we synchronize it with in a specified frequency with the reality. So basically, we put in the data that the system is generating. So the aim is basically to get like this holistic understanding of the system and the interaction with like plants and climate, and to allow decision making and to take some actions on this system. And we use real-time and historic data that we generate from the sensors and from like weather data, and we can simulate like predicted futures, or we can say what might happen in the future with this system. And so basically then the digital twin, or the motivation of it, is to create like a tailored use case, which would then be like the irrigation system. And it is built on data. So basically we can match the reality with a data model, and we implement therefore like the IoT systems of like sensors and actors. And so the motivation of all this is that at the moment, when we look at smart irrigation, what we have for like technology today, we basically look at evapotranspiration. And we like have the ET influencing the runtime of our system. And at the moment, on most of the like commercial or residential projects, we have a lot of stuff that we don't know. So we don't, like the controller doesn't know anything about the irrigation type, or if it's sun or shade, or if it's like what soil type it is, or which plants are growing in there. And also, like, well, the user puts in some irrigation times and some cycles, but we don't know why he puts in this data. And also, like the topic of soil moisture, what we were talking, it's like how to interpret it, or how to match the location of the measurement of soil moisture with the garden plot. And so basically, the status is still that we have some ET adjusted smart controllers, but the decisions they make are based on like user settings and lack of relevant information. And therefore, basically, we came up with this point that we have so much going on in this whole soil, climate, plant system or environment, that we might look for some more information and some better models to make decisions for irrigation management. So basically, like we just said, we have this evapotranspiration, irrigation topic, we have the soil topic, and even with the soil moisture, like depending on the type of soil, we have very, very big diversity of like field capacity and wilting point, that every soil type is giving a completely different need of water and irrigation management. And therefore, like we come to this topic of like, what should a digital twin take into account? And this should be like the living environment of the plant. So basically soil type and sun exposure. It should take into account the system settings, that basically it knows about the sprinklers, the drip line, the operation times. It should know about like the characteristics of each irrigation circuit, basically the irrigation uniformity, the precipitation rate, and then create this with the weather data and soil moisture data to generate some good model. And then there are some upside potentials going to system integrity, that basically the system can detect some pressure failure or some filter clotting, and we could also think about some process optimization in the future, which could be like fertigation or rainwater management. And so basically this is then the setup that we came up with, to have basically one block of data entry where you put in like the CAD planning software, and this software is directly connected to the data visualization. So basically you have like the direct digital link between creating the system and visualizing the data of the sensors, and then you have the IoT data, which comes in from sensors and online databases and weather stations, and it could be then connected to an API of a controller, which, for example, we can use the Hunter Hydrovise controller to connect our API to the controller. And so basically then we have like this interwoven concept of the irrigation plan, the irrigation data and controlling, and the sensor that feed in the data, and which could be like a possibility also to have some digital kind of auditing and operational control. And so when you now go briefly through this concept, then basically we have this data entry where we can design the irrigated areas. So we draw to scale, we define the irrigation type that we say sprinkler and drip line. And basically this is the layout basis of the irrigation system. Then we can add the sprinklers. So we define within the system the position of the sprinkler, the spray radius, and basically the type of sprinkler. And this allows us to already calculate the precipitation of the area, and we can compute some distribution uniformity. So basically we have this like non-watered, underwatered, well-watered scenario where we can say, okay, there is some impact when I do wrong irrigation design, and get feedback to the designer or to the later program about distribution uniformity and like runtime elongation. And basically, yeah, this is the basis of the precipitation calculation and runtime calculation for the system in the future, or in the operation. Then we can do some hydraulics and pressure drop layout where we say we define the circuits, connect the sprinklers which are controlled together, and this basic gives us some clustering options that we say we can specify each circuit with some like soil type, plant type, or sun exposure information or data. Coming to the soil moisture, like one of these concepts to really say we can position soil moisture sensors in areas that are only hit from one circuit, and then say this sensor data is really matching the irrigation regime of this one circuit. And so basically we define the representative locations for the sensors. We assign sensors to irrigation circuits, and this is then the basic for monitoring and understanding if the irrigation management is like correct, and we get some nice wet-dry cycles in the soil moisture. And it's also like a basis to assign circuits with no sensors to the same settings. Like we said, we have circuits with similar properties, then we can assign maybe 2 or 3 circuits to one sensor, and then say like we treat this in a similar basis. And then we start with the visualization that we say we get in the sensor data, we assign like a plant type, we assign some limits of like maximum soil moisture, minimum soil moisture wilting point, and we install the sensors in different depth so that we can like say middle of the root and under the root to prevent overwatering, but to get like an understanding. And then to like do the first like initial controlling, we can like connect this controller via API key, and then say we want to like interrupt the irrigation for like 24 hours when basically the like threshold for minimum soil moisture is not met or will not going to be met in the next 24 hours. So basically this is the like setting up the system. And then when we go to like controlling the setup in the future, we go into like a deeper detail where we say by using the distribution uniformity and the living environment, we can get the understanding for watering needs. And the living environment will then be basically correlated to sensor data, and like a precise water demand can be calculated. And these algorithms then will do the calculations, make the decisions, and also will be able to detect anomalies. So when we see like strange behavior of some sensors, we can say, okay, this will have to be checked, and then basically then design and enable the auditing process and transfer like the knowledge that the irrigation designer put into designing the system and transferring this knowledge to the operator and to give him all this information basically. And how we would like to do it, or like this is the concept that we are going to follow, is really to take the geolocation, to give some like blocking times when no irrigation should happen, but then the system will just automatically like run the whole irrigation by the local definitions. So basically for every valve, we set in like the condition, which is it like a dry or like a moist condition that we want to generate, what type of vegetation is on this circuit, what root depth will have to be like watered, and what soil type will be in the in this irrigation zone, like 3 types, like sandy loam, mixed, and clay. And then we can also set basically the sun exposure to say if it's like shade, partial shade, or completely sun. And from that, we can calculate basically the parameters. And then to define the runtimes and to define the runtime intervals, it is possible then to link the data to the irrigation type of the circuit and to match this basically with the precipitation rate and to run like the irrigation regime. And by that, we can basically then say we want to move like in this available water matrix that we want to set the irrigation setting within. And yeah, just one more thing, like to control the whole system, you can also like connect pressure sensors to irrigation systems to understand pressure drop over the filter and like initial pressure of the system, just to see when does a filter have to be flashed, or is the water source maybe decreased because of like pump defects, and this will also feed into the system. And basically, yeah, as a summary, we will increase the water efficiency with this concept for gardening, landscaping, as well as for agriculture in the future, when we say we get all this data into our calculation models. By creating this digital twin, we can use the sensor data and the information about the living environment to understand more of the humidity status in the soil, and to understand more of the system integrity and the demand of the plants. And yeah, big next task to create this robust algorithms to monitor and control the system and to make predictions and anomaly detection. And well, this is the next things to do, like to understand the parameters, and we will start doing the field tests in this year to have this vegetation season to evaluate the model. And then we are open to discuss also with the EIA to like transfer some of this technology maybe to increase like the potential of saving resources and allowing some digital auditing or cooperation between designer, gardener, and system operator within maybe the urban landscaping group. And that was it. Thank you.
Thank you, Andreas. Thank you very much. It's now we're open for questions. Actually, I do have one question for you. I think I already asked the question, but I don't remember. Are you dealing as well with the drip irrigation, or is it open at this point for the sprinklers?
Yeah. So basically, we have the drip irrigation for all the like flower bed and the hedges. So this was the purple areas. So there is the drip irrigation going into the system.
Good. Thanks.
Damir, you have a question?
Yeah, I would like to ask what I didn't quite understand is how does this fit into a standard process of making an irrigation design? For example, in most cases, when you're designing an irrigation system, you're designing it for the project which is still not there. New house, new commercial development, new park that is being completely renovated. So the idea here, as far as I understand, is that you zone your system in the way that you can apply different amounts of water to different distinct areas. Basically, in the standard design process, this would require that you first carry out a complete research of the site and some kind of a learning period, but you cannot do it before the site is finished. And when the site is finished, the irrigation system already must be there. So you don't have time for your research of specific areas.
Yeah.
Basically, what you need to do is you need to anticipate what may happen there and zone your system accordingly. I know very often from the practice, when you design a building and then 2 years later, when the plant material develops, starts delivering shade, where the shade did not exist in the first year, you need to do something on the irrigation system. So to me, this seems like an approach to improvement of existing irrigation systems, assessing, auditing, putting sensor data, learning about the location, and then proposing a retrofit of the system to be more in tune with what you have in the field. But what I would like to ask you is, how do you see the initial process of the irrigation design from the beginning? How would you make decisions on how to zone a project, except for standard guidelines, which you already know from the literature and experience?
I mean, yeah, it's a very good point, Damir. And I think there are iterations. And basically, when you design a project today, you already have to make some estimates or some you have to make some guesses. Or you take the time and research the site and interact during the planning phase already with the concept of the gardening. And basically, from that point, I don't see a difference on how you do it today, because you can design the project and you can make the zoning, and then when the system is installed, there can be an audit to say, okay, the zoning was at least plausible to that moment when the system is built. And in the future, when conditions change, you can change also, in some parts at least, the sprinklers or the setting of the system and react over the years according to the changes. And you can also do this with this digital twin when you start altering the data that you put into the system. So I think there must be then some versioning of, initial setup of the system, and then, after maybe 5 years, doing these changes and just duplicating the changes in the digital and in the real world.
Hey, Ichiam, you can ask your question. So you raise your hand.
Yeah, thanks a lot. Thanks, Andreas, for sharing. Very interesting. Just one question is, from your test and researchers, how far is your method of searching for the soil type, for the crop type, for the local climate, for the irrigation system, all of the things, how far was it in many cases, then let's say the basic traditional evapotranspiration multiplied by the crop coefficient approach, which is taken down today. So from your evidence, if you can share with us.
Mm-hmm. So, I mean, basically the evapotranspiration is still like the major calculation figure. But by making some corrections of the evapotranspiration by less, like you say, like the crop factor, or like the sun exposure as a factor and the soil type as a factor, then you can tune the evapotranspiration factor towards more like a realistic scenario. And this is done then by this settings per irrigation circuit. And the soil moisture sensors then can feed back the information if this was kind of plausible what you were doing. And
Thanks.
from the depth, I mean, at the moment we try to get like maybe 3 or 4 steps, like to say you have 3 different types of like sun exposure or 3 types of soil. And by that you get of like handle it and don't make it even more complicated. Yeah.
So what comes to my mind as the practical idea from this is that in the irrigation design, you decide to somehow evaluate what is the maximum number of electric valves or zones that you can afford on this project. The more valves you put, you get more individual control over a certain area where you can, in theory, ultimately control each sprinkler individually with a lot of meters of pipe underneath the ground though.
And only one valve, no, one valve at each sprinkler.
Or exactly. So basically, the idea then for the irrigation designers is to design the smallest possible zones so you can later on, after the research, apply water more precise to individual zones. Now, the question for you, Andreas, you know the real world. How does that correspond with the real world and with you know being able to exist in the market? So
yeah, I mean, a couple of years ago, I read this concept of IoT. You know that they say basically everything that can be measured, like will be measured or will be possible to measure in the future, because the cost of sensors and the cost of like controlling will decrease over the years. And so the guess is that the cost of measuring something is going down and the cost of water or like the scarcity of water is going up. So basically then we automatically run, and even if it's taking 5 or 10 more years, we run into this scenario that there will be a closer control of what you're doing. And for the irrigation system, I mean, even for today, when we say we have maybe circuits that cover, I don't know, 50 square meters or 100 square meters, I mean, this is already a step when you say, okay, I address some irrigation management, at least like plausible for this area. And maybe in the future it will be even more granular, but for today I think it's pretty okay to start like this and to say what we do at the moment and sketching out the system like we do it at the moment, but putting it into the digital world and try to understand what happenings during operation is fine for me at the moment. I think I don't have to drive it even more at the moment.
If I can add a comment here, Damir, I think that this is it's a great question, because we're facing the all of the sector, agriculture and landscape, other type of applications, we're heading to the same place. At the end of the day, it's a matter of balance, because we are here to introduce the technologies for the precision, no matter what kind of precision. It can be the good out, like the drip lines. It can be the controlling method, the IoT, the connected items, and so on and so forth. We're here to present the technological ability to go furthermore with the precision. And in parallel, we see that the market is going the same direction. The market, I mean, it's the political narrative, as you know, but as well as I do, Demir, we're very much into this together. There is what maybe it's going to be the cost of the water one day will be such that will be profitable enough to justify more investments on the equipment. Maybe the restrictions of the water will be such that there will be no other choice, but really to proven very, very efficient system. So I think the agriculture, and I was really happy to learn about the urban perspective and to hear your conversation here. I think that we're heading the same way, the same direction. So it's a very, very encouraging discussion at the end of the day.
Okay.
We'll push it. Good. Any more questions or comments to Andreas? All right. Good. So, Fleur, do you want to close this session, or do you want me to?
Yeah, thank you. I wanted to thank to all the speakers for this very interesting presentation, and say to the people who are attending this meeting and who are not member of the association yet, we invite you to join us. And if you want more information about our activities, about our events, forums, working groups, you can connect on the website of the European Irrigation Association, and you will find information there. And if you need any additional information, please send me an email or to Moshi or Bruno, and we will be very pleased to give you these information.
Thank you. Thank you. So just last words. Well, it can be from your side. The microphone is open, and we have many people on the call with the cameras open. So I'm very, very happy. I see many faces here. If you would like to add anything or to ask anything or to comment, this is the right time. So please go ahead. Don't be shy. Well, our new guy in town, EIA Sketch. Please go ahead. Hi, Philippe. You're mute. It happens all the time, don't worry.
Yeah. Hello, guys. Hello, everyone. Thanks for having us. My name is Philip Rotsenko, and we just participated the European Irrigation Association, and what is happening here and now is really amazing for me to hear all about that. Thank you, Andreas. We know each other because we are from Germany. We talked at Galabau about all this stuff that he's promoting, and he really makes sense. And what I think on this topic is that we have now a lack of enabling technologies that are coming. And when they come, everything that Andreas told us will be real in the real world, and we can measure everything very precisely. So this is just a matter of time. And as he told also, the water is getting higher. Technologies are making more democratical prices, and someday it will be really balanced and we can get to it. So that we also thinking on this topic, of course, as a software, and we are now providing mostly the online design and enabling our contractors to make their designs on their own, offloading some work from the bigger guys who are selling stuff and who are providing them with this. So we're working on this, on the simplicity and so on. So we are really in the same field, and I'm really happy to be there. So it's very interesting to me to develop, to open this world of European Irrigation Association. So thank you everyone. and let's work on every topic. We are open to do this. I heard that Damir is now working on the knowledge transfer. We can participate in this thing because we can provide our services for free, for example, for just sketching some drawings, and there is a really big amount of help that we can bring up to. I believe this. So.
Thank you, Philip. This is very encouraging, and welcome again.
Thank you.
As Fleur mentioned, there is room for everyone. We are just providing the platform and the opportunity to exchange, and then all the rest is by us, like by you, by me, by everyone in here. So thank you very much for everyone for your participation. Any more comments or questions, remarks? I think that's yeah. So at this point, let me thank officially, first of all, to the people who are very much engaged in the work of the association, the volunteer work of the association, and I encourage you to join. The ones who are not heavily involved to join us. It's fun. We're doing good things. I'm sorry, good things here. Special thanks to the speakers, Annette and Claude. Thank you for taking us to the roots, and Andreas. Thank you for opening the urban application representation. Big thank you to you, Fleur, as always, for managing this and for taking care of that everything is here okay, together with Jean-Maurice next to me here. We're keeping an eye that the IT is working well. So thank you, Jean-Maurice, as always, for this one. I wish you a very nice, what's coming now, the weekend. I can still say a happy new year because it's still January. The last moment. Let's pray to the security of the health of the people all around the world in all the zone of the conflict, and let's enjoy this coming year. Thank you very much, everyone, and the forum is closed. Have a nice weekend. Bye-bye.
Okay.
Thank you.
Bye-bye.
Bye.
Thank you.
Bye.
Bye. Bye.
Bye-bye.
Bye.
Bye, thanks a lot.